Everyone, welcome back to another edition of the LlamaIndex webinar series. Today is a special workshop hosted by Wenqi Glantz, who's a key contributor to LlamaIndex, has contributed a ton of really great blog posts and educational material on different, both basic and advanced functionality that LlamaIndex has to offer. And today we're really excited to kind of be doing a workshop on this idea of evaluation-driven development, which is basically this core idea that as you're building RAG, everybody should bake in evals in the loop, so that not only do you just try out the basic stuff and leave it at that, you actually try to set up some sort of evaluation benchmark. And then as you try out more advanced techniques or ways to improve and optimize your RAG system or LLMM, then you can actually in a more principled manner, iterate on this, try out different techniques and compare the performance against the baseline. And so this notebook will be a workshop. I think someone in the comments asked whether or not this link will be shared. Wenqi, if you want to just paste the link in the chat, then yeah, let's do that. And then this recording will also be up on YouTube as well. So if you join a little bit later, then it's totally fine. We'll have this on YouTube along with the notebook. So without further ado, thanks Wenqi for coming, and let's get started whenever you're ready.
Yeah, I'm going to paste the link first so people can follow. Okay, there you go. Okay, so thanks, Jerry. Really appreciate it. Evaluation-driven development. So this topic, it's relatively new to me as well. So the first time I encountered eval is really from Logan's webinars, Discover LlamaIndex series, part 3. Focused on evaluation. I learned a great deal from there. So highly recommend if you're new to eval, start with that and really in-depth dive into how eval is done using LlamaIndex evaluation modules and the ins and outs. So this is highly recommended. 16 minutes, well worth your time. And then also from Simon's tweet, he mentioned evaluation-driven development. So that's really the first time I hear this term. And coming from a traditional programming background, we all most of us are familiar with TDD, test-driven development, right? So this is in the LLM application development world. This is sort of similar to that in the way integration test-wise, you're having the test-driven development. For this is evaluation-driven development. So today's notebook, we're going to focus on this eval for a multi-document RAG pipeline that I developed, actually use it as a sort of sample app for many of my evaluation experiments. So what this does is I have a multi-doc data folder here and 3 DevOps self-service documents, PDF documents, and it's actually extracted from my own blogs. And then we use that to load it and process it using GPT 3.5 Turbo, and also going to experiment with the new Zephyr 7B Alpha, which really came out last week only, and it's brand new and very exciting. Just experimenting it and to see how it compares with GPT 3.5, and the finding is actually pretty inspiring. So we'll go into all that details. And if time permits, we can actually jump on to another notebook after this, but let's see, hopefully. So the bottom line is that eval, EDD, we call it EDD. Why do we have to do EDD? So this is let me see if the diagram is too big. I'll just shrink it a little bit. So this talks about the benefits of EDD as we from TDD perspective, right? So we understand the benefits of that. So in the EDD world, it has this 6 benefits, really. It's sort of the highlight, enhancing the accuracy and the relevance. So I also have detailed explanation here, so feel free to explore that as well. Identifying weakness and opportunities. This obviously, we can compare a lot of different tools and the techniques that we can evaluate and use this approach and find out what works best for our particular use case. And also guiding model selection and parameter tuning. In this particular use case, we're actually going to use that to guide our model selection. Parameter tuning as well. I just wanted to also mention that Ravi has a wonderful post published a little while ago on the chunk size using eval to handle the chunk size selection. That's well worth it. Highly recommended. So all of this, it's all part of the EDD kind of methodology. So also can use that to ensure the robustness and the generalization. Or just to help us to make our pipeline more robust and generalize capability. Align with user expectations. Obviously, we wanted to make sure our pipeline is as accurate as possible. So use that this particular tool to help reach that goal and to fine tune in areas that there are a lot of areas can be we can use EDD to fine tune. Continuous improvement and the iteration. So that again is like use that as a regression test suite of your pipeline. So all of this, just a handful of benefits, but there must be more, I'm sure. So just starting with there. And how to implement EDD. So mainly 4 main steps. So you use, just want to also mention, this is all from LlamaIndex, the evaluation module. So they have evaluation, response evaluation, and retrieval evaluation. So highly, highly recommend that. Go to, if you haven't already, check it out. They just gone through, massive kind of enhancements and included a lot more evaluators. So highly recommend to check out the details. And faithfulness and relevancy are the ones we're going to use for this particular pipeline. But if you have as ground truth and whether you can use a correctness evaluator or just explore all these different evaluators and use them to your advantage. So we first use the dataset generator to auto-generate a set of evaluation questions. So going to that in details, here is high level only. And then we define a set of evaluators for, right now for this RAG application, we define for faithfulness and relevancy. But again, as I said, you can add additional ones as you see fit for your use case. The third step is we use a batch evaluator runner to asynchronously run the evaluation of the responses. So here you see this batch eval runner. This is really cool, very cool idea, because used to be we'll have to run eval one by one, but here with batch you can combine one or multiple together and run them and define the number of runner worker to asynchronously process the responses. And then you can compare the evaluation results. So this spits out the results and we'll compare. So here on the diagram, let me just shrink to see the whole diagram. On the diagram, you may notice that data set generator for this particular application, we're using GPT 3.5 to generate the eval data set. So we generated a bunch of questions, but we randomly selected 30 of them. And then we feed that into the batch eval runner. And the batch eval runner, we're currently using the faithfulness evaluator and relevancy evaluator. Because I don't have the ground truth, so I don't do the correctness, and also guideline don't have that as well. So semantic similarity. So encourage you to explore that and understand what they are all about and use them to see if it applies to your use case. And with this evaluation, one thing to point out is that we wanted to use a superior model to evaluate our existing model. So currently, as we all know, GPT-4 is the most powerful right now model out there. So we're going to use GPT-4 to evaluate. The question, you can use GPT-4 as well. So some asked, can we use GPT-4 for the question generation? That's totally fine. In this case, we're using 3.5, but the eval, the evaluation is the main part. You do want to use a superior model to handle that. With that, the evaluator get passed into the batch eval runner during the construction of the runner. With the evaluation data set passed in, and also the query engine. The query engine, whichever you're depending on that the two approaches will go into the details there. So the query engine gets passed in, and then it produces the results, and then we'll compare the results. That's pretty much high level. So now let's drill into the details of the code. Go back to. Hopefully the screen is big enough for you to see. Here we install a bunch of libraries. Obviously, LlamaIndex, last I checked was 46 got out, I think, this morning. So it's amazing. The develop at the speed of light, I always say. PDF, obviously, we need to upload as PDF documents. Sentence transformers we're using, and transformers accelerated, and bits and bytes. This is all used for the embedding model and as well as the Zephyr, the LLM. And the bits and bytes are really used for the quantization to shrink it to 4 bit so that it can run on the Colab. As you notice, I have this T4 high ramp turned on. So initially I tried to do the T4 on the free tier. Actually, it failed during download. So be aware, you can try it with the free version, but if you run into any issue, suggest to upgrade to a pro, which is like $9.99 for a month, well worth it. So try it out. And even if you upgrade to pro, make sure you have the high RAM turned on, so that go there, go to the runtime settings. So make sure you have the high RAM turned on. So without it, I also had a failed experience as well. So make sure the T4 and high RAM, that should work. I have that mentioned in my blog, so you can check that out, details. But so we install the libraries. And for this one, for the multi-document RAG pipeline, so there are many different strategies. So for this one, we're going to just pick the metadata replacement plus node sentence window. So for that, again, I just wanted to point out the production RAG. LlamaIndex has a wonderful page put together with all sorts of techniques and strategies to handle for production grade, RAG pipeline. So highly recommend to check it out. And in this case, we're picking the metadata replacement plus node sentence window for multiple reasons. This is, we did it for one of the previous pipeline, and that one used the recursive document agents. But in this case, we cannot really handle agents because of the one of the limitation is that Zephyr, LlamaIndex did a benchmark here that out of all the advanced RAG tasks, it really outperforms all the other 7B. But with data agent, it's still struggling. So for that reason, we're not using agents or multi-doc agents or recursive document agents for this particular piece. We're just going to stick with metadata replacement plus node sentence window. What that is really helps us to for tasks such as, okay, so this is essential to make sure that for large documents, retrieves the more fine-grained details. So we also wanted to just quickly touch on the table of contents section here. How we're going to approach this is we're going to do the general, the common tasks first, like load the documents and set up as a node parser, service context, and all that. And then we're going to implement with the two different approaches. One is using GPT 3.5 Turbo. All the steps are the same between this and the Zephyr, which is extract the nodes, build index, define query engine, and run the test queries. So all those, the two sets of implementation. And then after both sets are complete, then we do the evaluation. So evaluation here is the 4 steps we mentioned above, generate the eval questions first, define the evaluators, then define the runner, and then do the final comparison to do the evaluation. So that's pretty much the high level there. So going to the details, here's loading the documents. Obviously, as mentioned, the 3 PDF documents. So load them using the simple directory reader, and then set up the node parser, service context, and so on.
Wenqi,
yes.
Sorry, this is just a quick question. I think someone was asking in the audience, is there a way to download these PDF documents?
Yes, it's in my repo, in my GitHub repo. And if you go to my blog, it's listed at the bottom. I have my repo link. Yes, right here. So if you go there, it's all the stuff is there. So
okay, yeah. Let me, how about this? I'll go ahead and link the repo.
Yeah, feel free to just put in chat. Yes, great. Okay, so we're setting up the service context here and also the node parser. And then we move on to the GPT 3.5 Turbo implementation. So in this case, we're providing the API key. So make sure we put the open API key here and define the ARM and embedding model. So in this case, you see our service context. So service context is where we define our large language model as well as the embedding model, among many other things. So in this case, we're defining the ARM, which is defined right above. Right here. So it's GPT 3.5 Turbo. And then the embedding model, I'm picking this one, the BGE base English v1.5. I wanted to mention that this is currently ranked number 2 on the leaderboard for the embedding model. And the number one is really the large version of it. So because I'm running a collab, so I don't, I might have with a pro version, but I figured I just use the base one. It's safer, and it really is a very powerful embedding model, ranked number 2. ADA, OpenAI's ADA is number 14. So that gives you an idea, how good this open model embedding models are. So that's why we picked this one. So you see I'm downloading to local here. And with that, executing it, you'll see it gets downloaded. It takes a little bit time, 44 seconds to download that whole thing. So that extracts the nodes and builds the index, vector store index with the nodes passed in. And obviously the documents there, we read it and put into this document list and get nodes from the document and then construct the vector store index from there. So now I have the sentence index, and now time for me to move on to do the query engine. Query engine is, pretty straightforward. The beauty about LlamaIndex is just so straightforward with, constructing of the query engines and so on and so forth. So as query engine, that's it. All you need to do. Similarity top K, and we define the node post processor. So that is the part that we define as the index as a query engine. Now let's run a test query. So in this case, I'm just calling. Notice I'm naming my query engine with like a metadata prefix. So this one is the default for the GPT 3.5. And give it a question, and I get an answer pretty quick, 2 or 3 seconds. And this one is 2 seconds. What is hard and runner in DevOps self-service centric pipeline security and guardrails? So I'm happy with the result. So move on now. Let's implement the Zephyr 7B alpha. So for this one, the implementation is slightly different in that in constructing the service context here, where first of all, where just a quantization to make it a 4-bit instead of the default 32, which it requires a lot more hardware. So this process allows us to be able to shrink the memory footage of this footprints of this particular model and make it downloadable to the local, in this case, collab to help. And also lose a little bit accuracy, that to be aware, but it's totally manageable in a way that you can tweak it whether to make it a 4-bit, 8-bit, and so on. If you have the hardware, you probably don't need to do that. And then the rest is really a lot is from the implementation of LlamaIndex in their documentation. This is code snippet from there where it defines the messages to prompt. So these are standard prompts. And then in here, this is where we call the Hugging Face LLM. Again, it's a LlamaIndex class that we passing the model name. So this is our Zephyr 7B alpha, and the tokenizer name, and also the query wrapper prompt. This is again the standard context window max new token and all that. So that is how we get our Zephyr LLM defined, constructed. So move on. By the way, it took 3 minutes to download that, as you can see here. So it does take a little bit depending on, so this is a way to step. If you run on free tier, you'll see error message. Maybe you're lucky, if you happen to have a T4 high RAM available for you at the moment when you try. But a lot of times if you fail, just encourage you to upgrade to the pro, just test it out. So that's the downloading the model done. And from there, we construct the service context. Again, passing the LLM and embedding model. So embedding model, we're using the same. So we don't want to compare too many variables here. We just wanted to focus on the LLM. So we use the same embedding model. And now you see the LLM, I have it with underscore Zephyr. So making sure we're picking the right LLM here. And the same concept here, extract the node, build index, define query engine, as we mentioned earlier. So here in this case, you notice we're doing the service context Zephyr, which is defined specific for Zephyr LLM. And also, that the naming convention, just making sure we're not mixing the two together when we do POCs like that to ensure that they're pointing to the right query engines. And here I'm running the test to query. Notice right here, you'll see 13 seconds compared to the previous was only 3 to 2 seconds. So here is one thing just to keep in mind, even though the response is very reasonably good, but it took a lot longer. Same question, by the way. So these are the test questions. This one took 7 seconds. So these are all the things, part of eyeballing it, you kind of get an idea. So now we have both of them up and running. Both query engines are functional. So now let's move on to the evaluation piece of it. First step is to call dataset generator to auto-generate the evaluation questions. So in this case, what we're doing, this is also, I saw a code snippet from LlamaIndex documentation. What we're doing here is we're generating the questions, and we're, in this case, I'm generating the whole question. I just curious, want to see how many questions would my 3 PDF documents generate. And interestingly, you see here 490 questions. Okay, good to know. So by default, how that works is 10 questions get generated by per chunk. So that's all the default parameter, and you can customize it however you want. This is all, the beauty of LlamaIndex with so much customization that you can customize to your need. But by default, that's the default behavior. So I generated 490 questions. I really don't need that many questions, so I randomly pick 30. So use this random, generation to pick 30, sample 30 questions. And then I save them into a text TXT file, so that next time when I run this, I don't have to, actually, this is the best practice. You should save it and use that as, tweak it and use that as your golden set. Why? Because you wanted to compare apples to apples, right? If you make changes to your implementation strategy or, LLM or embedding models, and you evaluated it with one question data set, and you wanted to use the same set for the next evaluation, just making sure that, the outcome is totally comparable. So to do that is you save it in a TXT file, and in this case, I have it saved. When you process it the first time, it will generate and it will save it for you. But I encourage you to go in there and look at the details of the questions and see if they all make sense. I mean, eyeballing it, you can do that. And also, you can totally manually add additional questions or, revise existing questions to it to make it fully relevant, kind of, that you have very good questions there, because LLM is good to some extent. We're using GPT 3.5 to generate this question. Even with GPT 4, you still could run into, 1 out of whatever 100 question may still not be relevant and so on. So it's a good idea to manually, make adjustments and use that as your golden set and save it aside. So here I generated, randomly picked the 30 questions. With that also, now we move on to define evaluators. So evaluator definition is, right now we're doing the faithfulness and relevancy. What is faithfulness and relevancy? Again, documentation has all the details, but I have it summarized here on this page on my blog. Actually, here. Faithfulness is measure response from a query engine, whether it matches any source code or not, or source nodes or not. So really focus on response matching source nodes. Relevancy is focusing on response and source nodes matching the query. So notice the difference here. So the query is in the picture here for relevancy, and faithfulness really looking at the response and the source nodes. So that's, again, it's extracted from LlamaIndex documentation. So just putting on place. So here, to get the GPT-4, we wanted to pass the GPT-4 to evaluate, right? So we define another service context here. We call it GPT-4_service context. And again, very similar. We use LLM passing GPT-4, and then with that service context, we pass to the evaluators. That's the only kind of, there are other parameters to be customized, but in this case, we're just customizing its service context to make sure that it's utilizing GPT-4 for the evaluation. So we defined the 2 evaluators and then move on. So in this case, I'm going to use these 2 evaluators to test out my initially generated questions, because I wanted to tweak it and making sure there are no bad questions in it, right? So that's a technique you can use these evaluators, and this also extracted from LlamaIndex documentation on displaying the eval data frame. So you basically wanted to display the query, response, source, and evaluation results, making sure that, so this is what it looks like. You have the query column here, and then this is the response it returned, and this is the source nodes that it's extracted from. And then the score, this is for the faithfulness. So it tested for faithfulness here, and it passed. So that's how you, if you see some type of, response is saying context not found in the provided documents or something along that line, that is a red flag. You probably wanted to change that question. So revise it with something a little more meaningful. So that's, just keep that golden set kind of handy and making sure you have it updated and, have all the relevant documents. So all that, once you have that all finalized, then let's move on to the batch eval runner. So the construction is extremely simple, as you can see. All you need to do is you pass in the evaluator in the key value format. So you have faithfulness, and that's the faithfulness evaluator. You have relevancy and the relevancy evaluator. And the workers is here. You define how many runner workers you want them to run, asynchronously to process your evaluation. So this one I tested it with initially with a pretty bigger number, and I run into, guess what, the rate limit issue, right, with GPT-4. So be aware, don't set this number too high. Default is 2. So, I would say under 10 is probably reasonable. But if you have over 10, especially you're testing from the same org with the OpenAI APIs, you're probably running into rate limit issues. So adjust that to be a reasonable number. Show progress is just to show that the bar, progress bar. And here, this is again, it's from LlamaIndex documentation. So get eval results, and this helps us to get the results and calculate how many passed compared to the total number of questions, and then gets that score. It would be 0 point something. 1 would be perfect score. So so that's how it's done. So then let's move on to just run that evaluation on the GPT 3.5. So this will trigger the runner, call this async evaluate queries function, and passing this metadata query engine. So remember, this one is defined for GPT 3.5. You can name it a little bit more obvious. I highly recommend it. So that's no confusion, because we want to make sure you're evaluating the right query engine. And then the query is here, you're passing the question data set, which is loaded above from the file or from the initial generation of the questions. Call the get eval results, and then that is you passing the key and also the eval results. This results basically has a combination of both for faithfulness and relevancy. So you here is splitting them up and display the score. So in the scoreboard here, you see 10 is, this one is like it took 10 seconds to run faithfulness for GPT 3.5, and it took 4 seconds to run the relevancy. And the score here is for faithfulness, it scored 29 out of 30 questions. So it's like, 0.9666. So it's pretty good. Which is we'll kind of expect in your GPT 3.5, right? So relevancy is 28 questions out of 30. So that's a little lower. So that's, good to know. So that's what we have. But I just want to mention, because I only selected 30 questions here. So in reality, if you want to bump that number up to 50 or whatever, whatever you think is valuable and reasonable for your use case, feel free to experiment it. And obviously, if you don't mind using a little token money up with GPT-4, so that's the only thing. I just keep that in mind. Now move on to evaluation for Zephyr. Very similarly, call the runner evaluate queries, and then this is Zephyr's query engine. Remember, we defined with Zephyr suffix here. So same question data set. So ensure that is the apple-to-apple comparison again. So what do we got? So this one is faithfulness is 28 out of 30 questions, and the relevancy is also 28 out of 30. Look at that. The score in this case is very close to GPT 3.5, which is encouraging. But the big but is GPT 3.0 took 15 seconds. And in this case, actually took 14 minutes. Well, I just run it right before the webinar here. So when I initially experimented, it took 4 minutes. But still, like, compared to the seconds of GPT 3.5. So just keep that in mind. And the accuracy may be there, but the latency definitely is still, there's room to improve. So just putting them on diagram, this is what it looks like, very close, which is good news. But the latency part is just keeping in mind as well. So that's pretty much for the Zephyr comparison with GPT 3.5. Jerry, you wanted me to move on to the other one? Do we have time?
Yeah, it's totally up to you. We could talk about the other notebook. You got up to like 10, like 28. You got like 20-ish minutes, but feel free to go.
Yeah. Okay. So we just talked about LLM, selection using eval, EDD. So now we move on to the retrieval method. So using eval to figure out which is the most ideal retrieval method for your RAG pipeline. As I said, on this production page, my goodness, there's so many different options. It's wonderful, the all different use cases. LlamaIndex has covered so much grounds for the open source community for us, right? So it's just a matter of us learning, understanding, and evaluating the right, the most fitting strategy for our particular use case. I stress for your particular use cases, for obvious reasons. One particular strategy might work for your my use case, but may not be fitting for your use case. So really use this EDD method to find out which one works best for you. So in this notebook here, we're demonstrating using EDD to decide between two retrieval strategies. One is a recursive retrieval plus document agent, and the other is metadata replacement plus node sentence window. Same exact, the three PDF files, and is generated the question generation and all the logic regarding that is all pretty much the same. So we wanted to just compare to see which strategy actually works best for us. So I'm going to go a little quicker here. Very much similar. We can go through table contents first. The comment has to load the documents first, and then implement the recursive retrieval plus document agent. The detailed step here. And then the metadata replacement and node sentence window, which we just gone through the detailed steps here. So once both are implemented, then we do the evaluation. The same step, really. The thing with that is once you do one evaluation, the other RAG pipeline will be so very similar. So you get a hand of it. Or just you can't do without it. Basically, your development it's indispensable and essential part of that. You use that. As I would call it a Swiss Army knife for your RAG pipeline. Okay, so load documents and implement a recursive retrieval document agent. So what that is because we are a multi-document pipeline, right? So this approach is based on each document. We create a document agent. So, and each document agent, we have two query engines associated with. One is a list query engine, which is really for summarization. And the other is a vector query engine, which is for Q&A. So each document, you have this set of, query engines attached to the document agent. And then before the traffic arrives to the document agent, we create this index nodes. Really a summarization, a high-level summarization of the document to sort of direct the traffic from the recursive retrieval query engine here. Question comes through, goes through the engine looks at the index nodes and figures out which index node they need to drop, need to route the traffic to. And the index nodes then goes to document agent. Document agent looks at the query, whether it's for summarization or Q&A, and routes the traffic accordingly, and then arrives at the answer. So that's a high-level kind of architecture that I think Jerry did that in like one weekend. One weekend, I got a tweet like he got this created. It's just amazing. So it's very effective, query retrieval method for multi-document processing RAG pipeline. So let's go into the details. So the detailed implementation here, again, we define the LLM. In this case, we're using the GPT 3.5. So we're not changing the LLM here. So the LLM stays the same. What we're changing is the retrieval strategy. So keep that in mind. So we're using the same service context across, and we create the document agent. So this again is, build your vector index, build your summary index, and you define your query engine and the defined tools. So this is the data agent, document agent we call, and then build the agent here. So then on top of that, we need to create the index nodes for the retrieval, recursive retrieval engine to point traffic to. So in this case, we create the nodes and have an index node here. So the document is summary. So the summary portion, just have to come up with something a little more brief, but still very specific to that particular document. So I noticed in my use case, the title makes a big difference. So I use the title here in my prompt here. So then you define the recursive retrieval and query engine. So in this case, we do the recursive retrieval construction and the get response synthesizer and construct the recursive query engine, passing the retriever, passing the synthesizer and the service context. Then we run some test queries with similar question from the previous notebook. So that's pretty much for the recursive retrieve plus document agent. Now moving on, we do the metadata replacement and node sentence window, which is what we just gone through, very much similar. So two types of, oh, by the way, here, by default, we're using OMP net base v2 as embedding. So that one, just keep that in mind. Define the query engine, run test. Okay, so that's fine. That's all done. Now move on to evaluation here. Same steps here. We first, generate the question and we define the evaluators, then define the batch eval runner, and then compare the results. So this block, again, you can totally reuse because we use the same block, to first check if the document exists. If so, we loaded the questions. If not, we generate the questions using the dataset generator. Same way as well, I'm randomly pick 30. In the case of if you don't want to, generate all questions, if you have tons of documents, right? You don't want to, it's not realistic to generate thousands or tens of thousands of questions. So just passing a number here into this generated questions from node and define a number, whichever you want, 50, 100 questions, whatever, just pass it in and it will generate only the requested number of questions for you. So keep that in mind. So we print out all our questions, which in this case is our golden set. How I know is because I sprinkled a couple of summary questions in there too. So that's my golden set. So that's why you can do such combination of, normal Q&A and also the summarization questions or whatever other questions you need for your particular use case. Evaluated definition here, again, using GPT-4 to evaluate. Very similar. And defines eval batch runner. Same way, in this case, I'm doing the 10 worker. This didn't give me trouble, so this one was good. I'm telling, just to be mindful not to define that worker too high, otherwise you run into a limit issue here. Same way here to get the eval results to calculate the score, and then we run it, defines the, call the runners, evaluate queries and passing the recursive query engine, and then this next is metadata query engine. So we can see here for the recursive retrieval plus document agent, we actually, the faithfulness is perfect. It got a 30 out of 30 correct. It's 1.0. That's like a hard to get number. Relevancy is 29, so only missed one question. So not bad. So GPT 3.5 for our, I'm not talking GPT 3.5, I'm talking about the recursive retrieval plus the document agent. So this gives us a really good result. We're using GPT 3.5 for both scenarios, so that's not a question. So now looking at the metadata for that particular retrieval method, and what we got 24 out of 30 correct. So that's 0.8. And the relevancy is 26 out of 30, that's 0.86. So the diagram shows, metadata replacement is definitely a little less than the recursive retrieval plus document agent. So that is how you use I call it TDD, EDD to determine, you evaluate this tool, you have a confidence, you have the insights to know this is definitely a better option for my use, for my particular use case. So that's a point why EDD is important and gives us insights into what strategies to pick and what LLM to pick, what chunk size to define, and a whole bunch other things. So that's pretty much it. Any questions, feel free to ask.
This is great. I think Yeah, I think I actually responded to most of the questions in the chat. But
great.
just to do some kind of shout out to Wenqi for like great content, and the repo is linked in the chat, and we'll also put it on the YouTube video description as well. And so we'll have the 2 notebooks. And so, yeah, thanks for running this amazing workshop. I think this is super comprehensive. I think people are going to find a lot of value out of this. And I think this really helps instill like great practices for users to, start off with experimenting with the simple things. I liked how you started off with experimenting with like the LLMs and the embedding model, because that's probably like the first thing that people should start with. And then as you go to more advanced stuff, start thinking about like more interesting, like complex retrieval methods and seeing if that actually helps you improve performance. So great. I think let's see if there's any other questions. Okay, it seems like I think we covered most of the questions actually in the chat. But Wenqi, thanks so much for your time. And hope the audience enjoyed it. And if you have any questions, feel free to hop on the Discord, and we'll have a recording up in a day or two, so you can feel free to comment there as well. Great.
Thanks, Jerry. Yeah, thanks.
All right. Cool. Yeah, let's end it there then. All right. Thanks everyone. And thanks for coming, and we'll have an update soon. Bye.
Thanks.